20 points for each blank, clearly. All right. So number 1. We're going over this. So 3 squares form a right triangle. Find the missing areas and fill in the table. Remember we said we have a formula that says a squared plus b squared is c squared. Well, if it gives us the area of this, and we called this side a, then what is the area of this square? Would be a squared, correct? So if we were to label 1 as a, 2 as b, and 3 as c, we could say that this area is just a squared, right? So a squared is 10, b squared would be 15, and we want to know what c squared is. So it's actually really simple. You say, what's 10 plus 15? 25. So what's the area of this box right here? 25. And that's it. Well, it's not. Okay, 20 points off. Yes. Yes. Next one. So now this time, do we know what a is? No. So we say a squared plus 20 equals. So anytime you have a right triangle, this area plus this area has to equal the bigger area. So this number for a plus 20 has to equal 36. So if we didn't know that was 16, we could subtract by 20, and we would see that a squared is 16. And no, we're not taking the square root of it because it's not asking us what the side length is. It's asking us what is the entire area. Okay? And the last one, we know a is 15, b is something, and c is. So 15 plus some number equals 40. If you didn't know that, you could take 40 minus 15. And we get 25. Okay, remember 20 points each. So you might be at a 40 right now. That's okay. Good. All right, number 2. Some people are confused because it's like, well, 2 of these answers look exactly the same. Well, unfortunately, it says circle the sketches, meaning more than one, that were correct. So we can start by getting rid of the one we obviously know can't be right. So a squared plus b squared c squared only works with right triangles. This does not have c on the triangle, which means that's not going to work. Okay, what was the other rule for our formula we said always had to be true? C is always across from the right angle would be the best word there. So which of those is that not the case? For the bottom left. Is there anything wrong with these top 2? No, so they are both perfectly valid uses of our formula. Okay. Number 3, find the missing side. So this is straightforward. This is just using our theorem. So which of these do we know? Which of these sides do we know? We know A is 12. We could also say B is 12 if you were feeling adventurous. And we know C has to be 13. This is across from the right angle. So we square our numbers. 12 squared. 13 squared. If we're solving for one of the legs, what do we have to do? We subtract the 2 numbers. Subtract. So we get b squared is 25. But in this case, we actually want to know the length of the side, so what do we have to do with? We have to take the square root. So what's the square root of 25? 5. Okay. Now we could do the same thing again for this one, or we could look for a relationship here. If we look at 13 and 26, are those related somehow?
Yes.
How?
You multiply them.
Multiply times 2. So maybe there's a scale factor of 2 here.
Yes.
Well, 12 and 10 doesn't work, but what about this side here? 5.
Maybe.
What's 5 times 2?
10.
10. So what could our last side be down here?
12 times 2.
12 times 2, which is? And for the people who worked it out, did you get 24?
Yeah.
Do you feel like you wasted a little bit of time?
No.
Good.
Because you didn't read it.
But you totally did. Remember I told you there was a couple of triangles that always worked. And this one, we should have been able to figure this one out without working out. How many times have we seen 5, 12, 13 now? Like a lot. Okay.
I just looked at my
And remember, any triangle similar to 5, 12, 13 will also work. In this case, we have 10, 24, 26.
Question.
Of course you do.
So, like, will it always be like 5, 12, 13, and could there be like 6, 12, 13?
No.
No.
There are very few that work out nicely like that. That's why you see 5, 12, 13 all the time. All right, number 4. This is where they try to confuse you because it's like, oh, I can't do this because it's like a triangle inside of a circle. And I don't even care. So let's, instead of just instantly giving up, look at it. So circle O has a radius of 5, which means anywhere from the center of the circle, any line going to the outside has a length of 5, which means OB, 5. OD, 5. Okay. So now, the question is, find the length of segment CB. Let's start with that. So here is CB right here. So now we're looking at 2 sides of a right triangle, correct? All we need to know is what is this short side on the left? Why do we know it's 3?
Because there's a 2.
There you go. If the whole thing is 5, from O to D is 5, but we have this little piece here that's 2, that means this bottom part has to be 3. Okay? So now if that's getting confusing, I can just take this same triangle and just draw it outside. I know this hypotenuse is 5. Shut up. I know this side on the left is 3, and we want to find, is this a leg? Yes. Let's call it B. This one you should know without having to work it out. So we have 3 squared plus B squared is 5 squared. So we have 9 plus B squared is. Since we're looking for a leg, what do we have to do with our numbers? We subtract. So we get B squared is 16, which means B is what? Why should we know that already? Because this is a 3, 4, 5. This is the most basicest. So then length CB equals 4. That's part of your answer. But then it also asks, what is the segment of AB? So what is this entire length across? 8. So if you didn't put both, count the whole thing wrong. Clearly. All right? So how they're going to try to trick you is they're going to take a regular old easy triangle. They're going to put it inside of something to try to make it complicated for you. Yes. Yeah, they did say that. All right. Grid shows John's home, his school, and the park. It gives you a hint here. It says from his house to the school is 12 blocks. How else could we have gotten 12? You could have counted them.
I counted them.
So that's sort of a foreshadowing to how are we going to find the distance from the school to the park. We count, we have 1, 2, 3, 4, 5. So how far is it from his home to the park? So if you can't see it. Somebody said count it. You can't count it because it's diagonal. We could work it out, but we already did. Good thing it's on your paper. So how far is it from? It's 13. Blocks. Right? Halfway there. Number 1 on the back, or the front, if you're a backwards kind of person. How can you find x in the trapezoid below? So if you did a written explanation, that's fine, but I'm going to do the math explanation because that's all I know. If there's a right angle on the left side, what does that mean there is on the right side? Okay, and now what do we have? A right triangle. What does x represent? C. So if here's our formula, a squared b squared is c squared. We have 6 and 8 as our legs, and I'm just going to call it c. So then we square it. 6 squared? 36. 8 squared?
64.
Now we're catching on. Since we're solving for c, what do we do with our two numbers? We just add them. That gives us. And then we take the square root of that to get just c. How should we have known that without working it out? Because this is a 3, 4, 5 triangle, just multiplied by a scale factor of 2. Okay? So again, if you put that in words, that's good enough. All right, this is kind of like the number 1 on the other side, except this time instead of looking at the areas, it just gives us the sides, which means we have to do a little bit more work with it. So again, 1 can be A, 2 can be B, 3 can be C. So we have our first one here, because some people are confused as to how can one square have 3 different sides? Because we have 3 different examples. I mean, there's an infinite number of examples, because any right triangle you can use this table for. Well, let me start then. What do you mean? I can't start because you're confused? How am I supposed to explain it and get you unconfused? Yes, it is. I know. It's not a cube. I don't know what you're talking about. 9 squared is 81. 15 squared. Since we're looking for one of the short sides, we have to subtract. Anyone who's anyone knows that 225 minus 81 is 144. That's just common knowledge, really. And we take the square root of that to get just b. Okay. Like some people are saying, again, this is a 3, 4, 5 triangle with a scale factor of 3. Okay? The next one, we could work that out, but there's decimals, and that's a pain. But if we look, if it's 0.3, 0.4, 0.5. Because again, it's a 3, 4, 5 triangle with a scale factor of 1/10. And our last one is not 22. Don't just look for a pattern. But we have already worked this one out, though. So I would like to not do it again. It's 10. Because this is a 5, 12, 13. We did that one.
6 times now.
Okay. So hopefully you're starting to recognize that a lot of these triangles keep showing up. All right, number 3. Given the right triangle below, write an equation that will be true for the lengths of the sides. This one's a little bit confusing and also really easy at the same time. Here is our standard equation, correct? So now all we need to do is say which of these sides is going to be A. Okay, E, which means F would have. And now all we do is we substitute A, B, and C for the sides we already have. So instead of A squared, we would write
E squared.
Plus,
F squared.
I don't know why I wrote 4,
4 squared.
equals,
7 squared. 24.
and that is your answer. You also could have had F squared. That would be the same thing. Yes, technically you could. All right, number 4. Find the missing sides. This is another common one, but we haven't seen it in a while, so we probably had to work this one out. So which sides do we know? We know A is 15 squared, and C is, so 15 squared, 17 squared. Okay, since we're solving for one of the short sides, we need to add or subtract. So minus 225 from either side. And that gives us 64. We take the square root of that. So one of the lesser known ones is 8, 15, 17. All right. And this last one, our first one that gives us a decimal for the day. Even though we don't use decimals here. This time we're actually solving for C, so it's 6 squared plus 7 squared. So 36 plus 49. Since we're looking for C, we need to do what? If we were to take the square root of that, I just changed it to the same color. That is between the square root of 81, which is 9, and the square root of 100, which is 10. If we look at the question, it says give the 2 consecutive integers it would lie between. So we would put 9 and 10. Make sure to read the instructions. If not, take points off. Yeah. All right. And the last one, a rectangle's length is 12 and its diagonal is 15. What is the width of this? 9. Why do we know that? Because we've already did it. Okay.